Assalamualaikum and good day to our lecturer, Technologist Dr. Nur Rashiki Miti Muhammad Noor. I am Muhammad Alif Mu'inus from Faculty of Civil Engineering. Today I will make a presentation for our project Numerical Method from Group 3, Section 5. Project title Group 3, Section 5 is Bisection Method, Enhancing the Critical Depth of New Drainage. For our group member, Muhammad Alif Muhammad Yunus CF220228, Pang Fei Ching AF220115, and Muhammad Ridwan bin Ismail CF220199, and Ang Yijia CF220179, and Saidatul Nadirah binti Ruzaidi CF220018. So for our content, introduction, and then literature review. Next is the methodology. After that, result analysis, discussion, and conclusion. Introduction. Numerical method, particularly hydraulic modeling, are used in analysis and design of drainage system. The bisection method appears as a basic numerical element in the dynamic field of hydraulic, blending in with the complex terrain of fluid system analysis and design. The reason for the need for a drainage system is to prevent excess accumulation and thus reduce the risk of flooding during heavy rainfall. The project aimed to reduce flood at Taman University by designing the drainage system using the bisection method. Problem statement. Taman University Parit Raja has recently experienced of open yet intense rainfall, resulting in localized flooding in the area. In response to this challenge, the local government has taken decisive action to redesign and upgrade the drainage system, recognizing the urgent need for a more efficient and robust solution to mitigate flood risk. The critical depth Y of the new design should not exceed 3 meters due to the natural topography and geology of the area, which has limited the depth of the channel. Objective 1. To suggest an appropriate drainage system capable of efficiently reducing the heavy flow. For Objective 2. To analyze how water flow across the drain along the proposed drainage system at Taman University Parit Raja, and then Objective 3. To determine the appropriate type and size of the drainage system for Taman University Parit Raja. That's all for me. Thank you.
So this is the villa table of this project. So we have facts, ideas, learning issues, and actions. So in facts, Taman University Parit Raja drainage systems is unable to handle consequently high rainfall that result in flood. So ideas is design and effectively drainage systems, and what we learn is how to mitigate the footings in Taman University Parit Raja. And by referring to the previous drainage system design and geology limitations is our actions. So next, the flow rate of the current drainage system is inefficiency to mitigate heavy rainfall. And the idea is to redesign and modifying the current design based on the requirements. And the learning issue is how to design a drainage systems. Actions that we're taking is redesign and modify the drainage system by taking MSMA second editions as a guideline. And the last fact is establishing the connection between the theoretical and practical domains and using bisection method to determine the optimum critical depth. And the learning issues is how is the bisection method applied in design of the drainage systems. And last action is design a drainage system by using numerical method learned in the civil engineering mathematics 5.
Hi and Assalamualaikum. My name is Muhammad Ridwan bin Ismail and my matrix number is CF220199. Today I will present about literature review for our project. First one, trapezoidal irrigation channel is the most common type. This channel can be calculated using the Manning equation according to Vettenkah A.R. 2023. Next, bisection method is the most common calculation for locating algebraic equation. If f in bracket a multiple f in bracket b have opposite signs, there is at least one root in this range. According to Reza Etasami, Mohsen Madadi, Masya Allah Mashinci, Reza Ashraf Genjoy, 2021. And the last one, to finding the root, the range A, B is divided into two parts, which is C equal A plus B over 2. If f in bracket A multiple f in bracket C is negative, the domain will be restricted by AC, and otherwise it is replaced into A, B. In each iteration, the distance length that contains the root is half. According to Reza Etasami, Mohsen Madani, Masya Allah Mashinci, and Reza Ashraf Genjoy, 2021. That's all from me. Thank you.
Good day to Doctor. My name is Anija, CF220179. We continue the presentation with the methodology part. So we will be using both qualitative and quantitative method to evaluate the critical depth for the Taman University Payaraja Johor drainage. So we will first define the problem statement and go for a site visit to calculate the old design flow rate. Then we will be propose a new design of the drainage and generate the bisection equation to apply the bisection method. At last, we will be do the result checking. The first methodology is the target area, which is a site visit. And here we will be survey the type of the drainage and also get the measurement of the old drainage. Then second, we will be using the Google Earth Pro to get the catchment area and also the high and low elevation of the drainage. Third, we will be referring to the MSMA second edition to determine the Manning coefficient of the drainage. And fourth, we will be using the open channel flow calculator to get the formula for the trapezoidal area and radius to put into the Manning equation to calculate for the flow rate. And last, we will be using the bisection method to find the critical depth among the intervals. Let's move on to the result and analysis part. And here we will be showing how we do the calculation for the flow rate for initial design and also the final design of the drainage. And we will be showing how we use the bisection method to find the critical depth for the new design drainage. So there are several data that obtained from the site visit, Google Earth Pro, and also the MSMA, which I have mentioned in the methodology part just now. So we have the catchment area, which is 4,359 meters square, and low and high elevation drainage, which is 7 and 9. And lastly is the type of the drainage, which is 0.05. Here is the comparison of the result of the flow rate for initial design and also the new design. If referring to the left-hand side, the initial design with a critical depth of 1.5 meter, we obtain the flow rate of 3.827 meter cube per second. However, if refer to the new design at the right-hand side with the critical depth of 2 meter, we have the flow rate of 5.976 meter cube per second. Moving on to the bisection method, at first we have to determine the bisection equation, just like I have shown in the right hand side on the top of the equations. And second, estimate the internal y values. And here we're taking 1.5 meter and 3 meters. Then we will be using the formula, which is yi equal to ai plus bi over 2 to calculate for the critical depth. So if referring to the left hand side table, we understand that for the fy9 value, which we get is 0.0003 is less than 0.0005, which means the critical depth for the new design is 1.9996.
This discussion section aims to analyze and evaluate the effectiveness of the mathematical models used to optimize the drainage infrastructure for efficient water management. And the flow rate of the old design was found, and we upgrade the drainage system to a new one to make it bigger and larger. The flow rate of existing drainage system was found to provide the baseline information about the current capacity and the performance of the system. Next, the flow rate provides insights into the peak flow rates and volumes that new system should be able to handle, because this is crucial to prevent flood and erosion. Next, the slope of the channel determined based on the Google Earth Pro. And the result of the flow rate for the old design is small, which is 3.827 meter cube per second, compared to the new design, which is 5.976 meter cube per second, larger than the old design. And the critical depth for the trapezoidal section calculated of 5.976 meter cube per second flow rate is 1.9996 meter. Next, the bisection method provides more accurate representation of the stormwater dynamics in Taman University Parit Raja. The calculated peak flow rates determine the capacity requirements for stormwater drains, and the bisection method used in this study to solve this because the bisection approach can be used to solve any continuous function that has two values with opposite signs. And the method is repeatedly bisect the interval defined by these numbers, then select the subinterval where the function changes sign, suggesting that it must have a root. And the bisection method helps to find optimum value by iterative design process by adjusting the parameters. But there are limitations for using this bisection method because the variability in soil permeability and the dynamic nature of urban development pose challenges in achieving precise estimations. So for future studies, we hope that the drainage system design could delve further into refining mathematical models to accommodate the intricacies of varying soil types and the impact of urbanization on water runoff patterns.
So I'm going to discuss about the conclusions. In conclusion, a draining system design has been created to improve or reduce the risk of flooding with advanced numerical method. In navigating the challenge posed by the nature, topography, and geology of the area, the pi-section method played an important role in determining critical depth for the draining system. In the initial phase, the measurement of the catchment area of the site, type of the channels, and slope of the channels were determined by using Google Earth Pros. Subsequently, Urban Stormwater Management (MSMA) second editions was used as a reference to design a drainage system in accordance with local standard. Mining equation was employed to establish a baseline flow rate for the new designs, and the bisection methods already bridged the gap between theory and practical applications. Through the implementations of such method, the design of the drainage system not only complied with the local standard, but also developed a thorough grasp of the hydrological features of the site. With this integrated approach, a more durable and efficient draining system is guaranteed for the project particular characteristic. The new design puts a notable increase in the flow rate from 3.827 meter cube per second in the previous system to 5.976 meter cube per second. This point is due to the planned improvements including an increase in the channel depth from 1.5 meter to 2 meters. The deeper channels will provide a higher flow rate indicating an enhanced capacity to manage large volume of water during intensive rainfall. This is a critical aspect in mitigating flood risks, especially in areas like Taman University Parit Raja. The increased flow rate suggests improved water management and division capabilities, safeguarding critical locations more effectively. In short, numerical methods assist civil engineer to represent, evaluate, evaluate and improve intricate systems, improving the effectiveness and reasoning of design and solution for a wide range of civil engineer use. That's all from our group. Thank you.